very happy to be with you today. It's a real pleasure to have this sort of meeting and see how it can be improved and improve the interaction with your company. I feel that your questions were pertinent, so I think that briefly I would like first to describe uh, the history, how I came, what I did, because it will affect the way to that I did research. I'm retired for 17 years, but I'm still working in the lab, which make me in the lab of Professor Su, and I'm working with a company in India using tools to collaborate, even to prepare large quantity of product. So my background, I have been educated by a woman who was a student of Professor Stork at Columbia University, and I got my PhD in Paris and take a leave to go to Harvard in 1970, working with Professor Corey. And I was in France as a CNRS, and in 1980, because I was very interested to see how it works in industry, I spent some time, few months in industry to understand and to play, and I enjoy it also. The tenure is that the context is in 1972, I had a position at the CNRS in France, and I was offered a position, a challenging position, because before it was no teaching at the University of Namur, no research laboratory, no scientific equipment, no scientific library. But you see, this was a sort of laboratory which is not the usual way. But I got one assistant, one researcher, as a strong financial support. And I thought it was a very pleasant to enter something new and to be responsible to what you create yourself from zero. The strategy, because we don't have students, is to train scientifically our students so they can themselves bring their money with their when they want to do the PhD research. And it was a way in Belgium where students can apply, and it is competitive. And my students get that sort of fellowship for about 30 years with a success of 99%. The other aspect was to train the student experimentally, so they will be able to go during their vacation in industrial scientific research and come back with some knowledge and being appreciated there. My interest is to start to work in a very large scale of reaction. Usually in the lab, we work on 200, 300 milligram. I plan to work with smaller amount, 10 microgram, and in this case, it is radiolabel, and also to produce in the same lab at university reaction which led to 1 kilo batch. That means 20-liter flask, which is very unusual because industry make bigger, university make smaller. And so I was very interested because this is a way, not all the students were working with 20-liter flask, but it was an interaction with the student to see something else in the same lab and to discuss with others. There is another aspect which is important, that when I came to Namur, I had a series of colleagues who were very interested for collaborating and helping me. this is very close to us at the University of UCL, was Professor Léon Gauzet and Heinz Fieux, were both synthetic chemists. They have been educated as postdoc with Professor Woodward at Harvard, who was already Nobel Prize. And so we have a team uh, there, but also, sorry, other professor you see here from Brussels, from Ghent, from Leuven. And so it was a very pleasant party to play together and to involve all of our students with the same rules and the same spirit. I have been approached around 1990 by Pakistan, Karachi, and asked me to help them. This is something incredible in the middle of nowhere. This is Professor Ataur Rahman. He has been educated in Cambridge and become professor. He create this laboratory. It is a laboratory involved in natural product synthesis, structure determination, and the laboratory has 1,500 scientists, which is unusual. This is his vision. That look, this is, he described that in 1994, 96. Economic development is no longer dependent on natural resource. Human resource is the most precious resource of a country. And so knowledge becomes the basis of socio-economical development. And therefore, it was an interesting place to work to help. He has a place, he creates a place where all knowledge can be seen in this system by contact through the web, and in a place where snack charmer can be seen, he create a laboratory of NMR with 500 and even 900 NMR to make structure determination and, of course, the people. And also, he has a lot of students coming from different countries, you see, and we are all living in the same place on the site. You see me here with many other students. So this is one of the approach. Let's see, if I have to bring my life in one slide, I had 99 master students, 38 students, 40 postdoc, and also 26 researchers. That means people who have already a PhD. My interest has been in chemistry of selenium compound, invention of reagent, inorganic and organic, as well as bioactive compound, synthesis of bioactive compound, pyrethroid acid or insecticide. To tell you, the amount is $3 billion per year, the selling of these. Anti-aging agent, MAO inhibitor, nitrogen fixation, and antiviral compound by collaboration with a company that I will briefly present. After my retirement, Professor Su asked me to come in his lab, and I enjoy this collaboration, first to discuss with the student and to use also his equipment to think about and to collaborate in a way that he is not an organic chemist. I'm not an inorganic chemist. But in fact, it is one chemistry, one word chemistry, and it was very pleasant to have this view. Bioorganic chemistry was one of the interests. The mechanism of steroid biosynthesis was for me an interesting thing that I learned from E.J. Corey. And also antibody, understand how you can create uh, an enzyme, an upzyme by yourself, trying to carry out a reaction by creating yourself the catalyst as from animal. And the interest there was that we have a collaboration, but we didn't like to work with killing mice and so on. And finally, we found that and test that all can be made with eggs. And so you inject a product to a poultry, and after 21 days, you take the egg, your antibody is on the yolk, you purify, you remove cholesterol, and you have a large amount of antibody. And this was a very pleasant presentation. So I will describe in the second part that I become interested by conceptualizing chemistry for building a computerized information system. And it was at the beginning of information and knowledge in that using computer. And in fact, I participate. Because I had a lot of money from industry, I was able to ask a question to chemical abstract. And it was terribly costly. It has to make a protocol to do that. And it was by telephone line. Internet was not yet there. And because I was asking question, I will describe that in the second part of my presentation. Chemical abstract look at me and ask me if I can collaborate in helping them to create Skyfinder. And I did it. So let's discuss that later. And I want also to say that during this type of research, you have a lot of other things related to science will come that you can be interested or not. And one of the interests come from this project who came through a collaboration with Professor Jean-Marie Laine, Nobel Prize in Chemistry, well known also in China, who had created a game, a sort of monopoly, but he was unable to make it usable. So he had the money, but no company wanted to create the game really, because it was chemistry, and chemistry is not nice, is a dirty thing. And so I said, don't worry. First of all, chemistry is beautiful, and other part, game is a game. That's all. And this game is very interesting because you win bond or atoms. And so you create your molecule as a molecular model. It has been sold at 5,000, created by the CNRS in France, paid by the CNRS, and transferred to different industry. I would be happy to do that, to create that on internet, to help the young student at school to play, but it was not possible. Many things you cannot do because you are too early in thinking. People don't want that. Sometimes you win, sometimes you don't win. This is, I will discuss the case of selenium compound. At the time, it was so that selenium is very toxic. I now is not the case. I will show. When I conceptualize chemistry, we got 2.5 million euro from European Commission. And the key problem was to discuss between humans using tools. We create a tool, and you see now, 25 years later, it is normal to be in China for you, in Belgium, with different people in different places and discuss chemistry. But at the beginning, it was very impossible. And you see, this is the way that I like things which come and you have to create or to test because many things doesn't work and then by chance you get some. I have been involved because Jean-Marie Laine asked me to help in IOCD, International Organization for Chemical Sciences, and I create a group with these people, all professor. Henning was the responsible of the German Chemical Society. Matley was Imperial College. Mehta, Professor Mehta was the one who advised the Prime Minister of India. And we have collaborated, acting with word to promote and reform chemical science collaboratively. And the notion of collaboration is also something that come that you understand that you cannot do that alone. And if you can do that with other, it is fantastic because you have different notions. The project, a LEGI project from that I got we got 2.5 million euro was 22 group. I was the only chemist. I I didn't understand what they are talking about. They were computer scientists, and but you see, this is very nice. I would like to show the last one is to promote science in Africa.
Wow.
And you see, we create this using uh, what is a system which engrave that sort. And you see, this is very different. This is the Ishango bone. I briefly what it is. It is present in Belgium as a natural science place. This bone is probably a babo bone. That is a scan way, and a laser did it in Germany for us. And we offer that to the African Academy of Sciences. You see, there's some strike here, 11, 13, 17, 19, all those are prime number. How people thought what was prime number, this counting of this bone was, he was created 20,000 years before us. How that come? It is probably the first mathematical object in the world, but we don't know. It has been extracted from a place. This is Professor Maza. He helped us to get the money to create that. And this is at the presentation, when we present that, you see the machine, the presentation here, the Ishango bone. This is Professor Amena Gourim Fakim. She was at the time the president of the Republic of Mauritius. She is a person who has a company also in natural product, and that is the ambassador of Belgium. So you see, you don't have to stop to your research, but you can open eyes and you see that in many places people can ask you and work hard
Oh,
because after that, when they
mhm,
leave, they can get position. For example, to tell you, so I think I'm organized. When I have a project, I never stop it.
mm,
That means, you know, let's discuss briefly a paper that I published in chemical synthesis maybe 2 or 3 years, 3 years or five
mm,
years ago, probably 5 years ago. And it is on steroid biosynthesis. Uh, it was, uh, I got information from the student I was working with, but I was unable to explain that, the results. I didn't publish.
mm.
The student got his PhD, but and when Professor Su asked me to provide a paper, it was 17 years after the
Oh,
PhD thesis of this.
mm,
But the PhD thesis was very well written. I
mhm.
have worked on that and understand what are the problems. And since I was retired, I was able to work one month, and I create this paper, which you sent to the referee was Sharpless, who had only one Nobel Prize at this time, and got a second Nobel Prize just after.
Yeah.
And he said he published a short notice about our work to say it was a very good work, which is unusual because the referee never signed the paper. He signed the paper, his appreciation to chemical synthesis, but he also signed me a paper as a referee to say congratulations. So you say it was 17 years. There are
Mhm,
three information on that. I was not in a hurry to publish.
mhm.
Maybe I was old already. I knew what was done 17 years before. And the PhD thesis of my student was very, very well written, described, so I can look at the real information inside.
Oh, that's
Uh,
definitely
cons-
something we should
yes,
learn.
so this is an important aspect, is, and this is probably what come from that. I
Mhm,
enjoyed doing chemistry. It
mhm,
was a passion and not a job.
mm.
And
Yeah.
so when I come to the lab, I discuss with a young student or I did my experiment by myself. I like, that's all.
Mhm.
Many
Yeah.
people say that I have to stop to go. No, I like that. I don't like administration, but of course I know that I have to do it.
Yeah, I
Uh,
mean, I see that passion. I mean, also from the strong promotion of chemistry by yourself.
yes.
Uh, Another follow-up question. Quite distinctively, you have a lot of successful collaborations with industry. So I'm really curious, like how did you develop all these connections and collaborations with industry, and in what ways did these collaborations influence your research?
Yes. The story is when I was younger, I thought I wanted to work in industry and not at university. I wanted to work in industry because I was not the one who give the project. Someone give you the project and you have to succeed. And the succeed is very simple. Not a number of publication is money. And
Mhm,
our life is money, finally. Unfortunately, it is the only way that we can live. And so when I was, before I came to Namur, I applied to an industry and was a big industry in France. And I went to the interview. And let's say, I will say before, at Harvard, the industry is coming,
Mhm.
and the industry is discussing with the student, the postdoc, and the student to hire people from what is say good university. Since I had the position, I didn't apply for the interview. But after some time, I was not happy because I was unable to ask. So I asked for a position of Man Laroche. And they asked me to go to New Jersey. They discussed with me and offer me a position. But I say I don't want to work in America. So they say, no problem, you can come to Basel in Switzerland. We have the. So I say, fine. They gave me, but in fact, because I was Tunisian at the time, I'm French and Tunisian, uh, I was unable to live in France and to work in Switzerland because of the rule. And I left. When I came back to France, I wanted to work in Roussel-Uclaf company, a very important company. They invite me. I present what they and answer their question, and they say, "Okay, we want you to become the head of our research, but there are different problems. The first problem is we want that you come as a young researcher, and then you have to come to the top because people thought that you are in a good position." I say,
Mhm.
fine. But they say, we cannot hire you now because we bought another company. There were 5,000 people who have been removed. And so the union will never accept that we take one more side. And during that time, the offer from Namur came, and I come that because I thought it was a good opportunity. 3 months later, the company say, okay, now all is solved with the union. You can come and work. I say, I'm sorry, I already engaged with, but they say, okay, what we can do, if it was a research director, he said, I would like to discuss with you. Could you come
Yeah.
once a month or anytime you want? You describe what you are doing, and we will discuss, only discuss. Oh, yes, I like very much. And so it stay about 4 or 5 years or maybe more. And I learned a lot of information because I was working and then they were discussing. And part of the discussion was related to their interest. And their interest, I can understand what was the interest and can do research having an information what is important. You see, it become a strategy.
Mm.
And then when I want to be in ICI, Plant Protection Division, I apply there and I was offered, yes. I didn't get money from that, but I was discussing and I wanted to work with a computer I didn't know, and it was a beginning. At the time, maybe you don't, you are too young to say that. When you buy a portable computer, A
Hmm.
portable computer is a computer who has 30 kilo.
Wow.
You were not authorized to bring it at home because
Oh,
people use this computer to play.
oh,
ICI had a different option. They say, yes, if I give you a computer, you can bring it at home and you can play with that. Because if you play with that, you will learn how to use it.
yeah.
And so I have been there. I bring a big computer because I was interested in understanding how it can be used for chemistry. And they helped me. Someone who was the head of physical chemistry uh, come and I say, I don't understand how to play with this computer. I don't know how to make program. And he say, oh, my interest, why don't you help me in synthesis and I will help you. He learned. And so after few 2 years, he left the company and create a company in computer science and programming. You see? And I learned something because he was doing for me things that I was unable to make.
Mhm.
And so this is, you will see, I will discuss other link to company. All time, if you work with a company, it is interesting because you learn something in different aspect. You can bring them something, but you get in return something that you cannot do that because we have not been educated to do large quantity or to
Yeah.
discuss the problem which are important for them, the money. They have to get the money.
Well,
Did I
that's really
answer properly
inspiring.
your
Yeah.
question? But you
Mhm.
will see other, and I will
Yeah.
explain how
Hmm.
I enter. But you see, you have to be curious and you have to take time to imagine things, and people will come, and then you have to choose the best to help you because you cannot do that yourself. But you can manage and you can learn.
Yeah. Thank you so much. Sorry for the interruption. Please go on.
No, no, I'm very happy. So let's see. The main aspect is chemical synthesis, and the chemical synthesis is very crucial because you can create things which can be used. Anyhow, you can smell, you can taste, you can sell, you can make on larger quantity, on smaller quantity. And that is a chance because when you have the knowledge of how to make a chemical, that you can make a chemical, and then you can imagine how to make it, you can help other, and they will ask questions so you can collaborate. It is in organic and inorganic, bioorganic, and material science. I will show you in this presentation how I enter all this field slowly and why it happened. So your question will have some sound in each of that. I have selected part which I have used. The subfield is reagent. We have created reagent. We have produced reagent for industry, uh, reaction, mechanism, synthetic strategy, and structure determination. Each time is a different project I will describe briefly, not the scientific part, which has been published, of course, but the way how it entered. And that was the objective I like very much from the managing part of chemical synthesis. How that come? As far as problem, I was interested by bioactivity, and bioactivity is, for example, antioxidant. Uh, Maybe this word you have heard in the TV and so on. People put cream and other. It's a wrong. place because you cannot have an antioxidant. Oxidation reaction doesn't exist. Redox reaction are. And therefore, if you have an antioxidant, it's a reducing agent. And because it's a reducing agent, it produces a product which can be an oxidant again. And therefore, the oxidant that you produce could be worse than the oxidant that you destroy because it is less oxidant and maybe have a longer time to stay in your body. So I will show you. So nature does that, understanding that it is an oxidoreduction reaction. The oxidant is reduced by another reaction inside of the body. Nature know that. And I was interested, I have been asked by a company to help to antiviral, and within 5 years, the product is sold by a company that Johnson and Johnson. And I was doing only the part of synthesis, and the conceptual part was done using 41 silicon graphic computer, but it was not the computer who create. People think that computer can replace human. No, it is your thinking that help is helped by computer and trace you the way that you bring plant growth regulator, selenium chemistry, organolithium chemistry that we enter through selenium chemistry, cyclopropane chemistry from pyrethroid that I briefly enter, antibody that I have mentioned, and steroid biosynthesis that I briefly talked to you. And if you look at antibody and steroid biosynthesis, it is a catalytic reaction that you understand what is a catalyst and how you can create a catalyst. Another aspect is I mentioned to you that it is crucial to have collaboration. And I decided, it was at the beginning of 2000, to bring together people, scientists working in this small spot. This is Namur, 220 kilometers around Namur. Why? Because Namur is a central part in Europe, and 220 kilometers, the student can come to Namur, for example, and return back at night. And you have a meeting, they awake at 5 a.m., they return back at 11, they have a scientific meeting, and also people know themselves. And so, let's see, in this 220 kilometers, you have Belgium, France, Germany, Luxembourg, and the Netherlands. All those countries have different language, but they have the same inspiration, the same way to work. And if you turn around these 220 kilometers, you have University of Namur, Louvain-la-Neuve, Reims in France, Aachen in Germany, Mulheim, the institute, important institute, was Nobel Prize from Kohl Institute, University of Amsterdam, University of Nijmegen. Our friend came, but we have also Eli Lilly, BASF, Johnson & Johnson, AstraZeneca, Bayer, Grunenthal, DSM those in Germany, that in the Netherlands, DSM Organon. and that you play with them, you discuss, and because you have make something no one pay, you do this, each one pay his own, and you have only to give for living in at midday a meal. That's all. And so no cost, but people understand, look at themselves. They make poster. You have people who come to give a lecture, and so it was pleasant. It is in the heart of Europe, at unique place where 5 different countries are in close contact with well-recognized university and research center. The other way is to organize meeting. We create a meeting, both in collaboration with all my friends there. The first take place in Namur. I suggest that company will offer a prize. The prize is a Janssen prize offered by the company Janssen that I know. Because of this collaboration, I will say, this is a meeting. This is Jean-Marie Laine he was invited, who gave a lecture, and before the lecture, he played piano on the sea, which is unusual to start with and then to start like that and then to present a scientific lecture in front of. This is also a very informative. This is Barry Sharpless getting the first of this prize. This prize was given to Sharpless 1986. The president of the jury, which has been selected, that I select, is there, Sir Derek Barton. And you see that he managed all. We didn't do, he play, and he select Barry Sharpless. As this is 20 years before he got the Nobel Prize. Mm. And the person who give him the prize becomes the King of Belgium 15 years later. You see, you have to feel what are the people, how they manage. And that is one thing that you have. We select one. The first one who got the Janssen Prize was the one who get 2 Nobel Prize later. And we were only able to see what he's doing is good. And the one who did it is the Nobel Prize winner who was the head of the president. So the selection of all came, but also collaboration with all our colleagues in 1986.